Okay, let's work on some error recovery. Even if we're not using exceptions, clients should take note if the server method is giving back a Boolean or some value, a non-null, let's say. It should check return values. But, even if we've decided, well, we're going to throw exceptions, we want the clients to not ignore exceptions. So what I mean by that is your code has to have a try-catch block, but you could just catch every exception possible and have an empty block statement that does absolutely nothing, and that will satisfy the compiler. You don't want to do that. The purpose of this is to come back from a problem. So let's look at an example where that might, see how this could be useful. Generally speaking, if we're trying to do something and it could fail, we're going to be in a loop. We're going to try to do this, and if it doesn't work, we need to, kind of resolve and give it another shot. So let's look at this with the possibility of attempting recovery for saving the address book. So we're going to start off assuming that we're not going to succeed, and we have made no attempts. Then we want to do a try to save and catch if there's a problem while we're not successful and we haven't tried too many times. If we're not careful, we could put ourselves into a state where the person tries to save and can't save, and tries to save and can't save, and tries to save and can't save, and tries to save and can't save. And it might be that they're never going to be able to save because of a situation beyond their control. And if we put them into what is effectively an infinite loop, the program would be stuck. So this possibility of we're going to succeed, or we're going to try a certain number of times and then say that is enough, we need to back out of this attempt, is a common pattern for this. So note that we have a do while block, which makes sense in this instance because the difference between a while and a do while is a while loop may never run, and a do while runs at least once because the question gets asked at the bottom of the loop. And since this is something we are going to want to try at least once because we've come in an attempt to save, this is a good loop construct. Okay, so what are we going to do? We're going to try to run the save to file. If this comes back okay, successful will equal true. We'll skip past the catch block. And then while not successful and attempts less than max attempts, well, attempts is 0. Let's say max attempts is 4, just pulling a number out of thin air for that. So 0 is less than 4. This is true. Successful is true. Not true is false. False and true is false. So this condition is false, so we fall out of the while loop. And then successful is true. Not successful is false. We skip past the if, and we saved. Yay, everything worked the way we wanted it to. But what if it doesn't work the way we want it to? Okay, we try to save to file. It throws an exception. Whoa, something's wrong. Okay, we can catch that exception. I'm going to catch the IO exception. I will print out unable to save to the file name we used. I will increment attempts. And if attempts is less than max attempts, I will do something over here which is just pseudo-coded in to set the file name to be something different. So like if you've downloaded a file with a given name and you try to download it again, Windows doesn't say you can't do it. It goes ahead and it appends like a 1 to the end of it, or copy, or something like that. So this might be the code where we go and say, okay, let's alter the file name and come back up, and we'll try to save to that new file name. Oh, through an IO exception, let's change the file name again, add attempts. Attempts is now at 2. That failed. I'm sorry, we come back up, try again. Oh, exception, back to the catch, attempts goes to 3, get a new file name. We're coming back up, throw another exception. We're here, attempts goes to 4. We set a new file name, but we get down here 4 is not less than 4. Successful is still false. So not successful is true. True and false because 4 is not less than 4. So true and false is false. We drop through. Successful hasn't been changed from our initial assumption. So if successful is false, not successful is true, and then we would report that we were unable to save the file and continue to move on with our code. In order to write code that is generally useful to end users, we have to do more work as programmers. So it's just not enough that it works, and it works when we're really careful about entering the right data. We actually need to anticipate places where it can fail and put in a lot of other code that's designed to handle these extraordinary circumstances. So just a possible way to go through attempting recovery from a failure. Now, another way to try to write defensible code, defensive code, is to try to avoid the error in the first place. So the question becomes, where is the code complexity? Is it going to be on the server side, or is it going to be on the client side? So if we're going to try to avoid errors, we can ask the server for a little bit of information, and we get that information, and then we check it, and then we move on and ask the next part of the process, and we ask the server, and then we get the information and we check it. This makes the coding on the client more complex. But it also means that the servers don't have to do as much work on their side because they know that the client object is going to be doing the checking. So, the downside to this is that the client needs to know a lot about how the server operates, and so we end up with increased coupling because if the client is responsible for doing all of the error handling, it means that we have a more piecemeal approach. It doesn't mean you shouldn't use it. It just means that you have to weigh the benefits and costs of doing it on either side of the transaction. If we're doing this on the client side, though, it does mean that if something goes wrong, that it's probably something that we couldn't anticipate. And so we have kind of unchecked exceptions where we just start to fail, close down the program gracefully. So it means the client logic can be a little bit simpler than kind of trying to do this robust error recovery on the server side of the transaction. So here's this avoiding an exception as an example, a little less abstract, a little more concrete. So in this case, we're trying to add information to the address book. Now, if we try to add information to the address book, and if the value already exists in the address book, then we just want to change and update that value. We don't want to add a whole new value. So here's sort of the structure to avoid an exception. Ask the contacts, is the key in use for details.getName or contacts key in use for details.getPhone? So we're going to get back details.getName. Key in use is going to give us one option, a true or false. Key in use here is going to give us a true or false. If either of these are true, we have an or. So if the key is used for either name or phone, then what we need to do is we're going to need to pass the details over to change details because the contact already exists, so we just need to update it. If the key is not yet in use, then what we will do is we will call add details with that information and create a new record. So these are the two possible ways that we could manipulate or deal with new information. And then if some other instance occurs, this is where we throw an unchecked exception because it's like, I don't know what the possible alternatives would be. It's a, it's kind of a more advanced example, but you should know that this is an option for when you're writing your code. So let's try to put a wrapper on exceptions because we still need to get to the issue of writing files. When we're writing code, runtime errors can show up for many different reasons. Could be the client's making a bad call to the server object. It could be the server object is unable to fulfill a request. It could be a programming error. It could be a network error. It could be user error. We want to try to anticipate those errors on both sides, in the client and the server, decide how we're going to handle those problems, use exceptions to provide either a recovery mechanism or a reporting mechanism. Recovery if we can, reporting that there was a problem if we can't. And if this occurs at runtime, to allow our programs to shut down cleanly, for example, closing files and other things so we don't end up with potential data loss, and then giving control back to the user and back to the operating system. One of the big places where this pops up is when we're trying to read and write files, and that's what we're going to handle next.